The energy comes in from the sun, it goes back out to space, but some of that energy gets trapped by the warm air and re-radiated back down, like a bunch of little heat lamps up in the sky. Now, you may have heard that the greenhouse gas that we hear about a lot is CO2, carbon dioxide. That's actually just a small amount of the air. 99% of our air is not carbon dioxide, it's nitrogen and oxygen, N2 and O2. But N2 and O2 are not very good at absorbing energy. They're both made of two atoms of the same element. So N2, two N's, glued together with a bond between them. Think of them like tennis balls on a spring or tennis balls on a stick. These waves of energy can come up and hit that ball on a stick molecule and start it vibrating, and the energy is actually then stored in the molecule. So the energy comes up from the earth, hits the molecule, and it starts vibrating like woo, 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 woo. But there's not a heck of a lot you can do with two balls on a stick. There's just not that many ways for them to move. CO2 is different. CO2 has three atoms, so there's a CO2. And as you can imagine, the CO2 molecule can vibrate just like N2 or O2. It can go woo, 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 woo. But it can also do other stuff. For example, because it's got three atoms, it can go wee woo, wee woo, or it can go bee boo, bee boo, or it can go bee boo, bee boo. And all these different kinds of molecular dances that the CO2 molecule can do will absorb different wavelengths of energy. So because it has all these different varieties of dances, or varieties of vibration that it can do up in the sky, it can absorb much more energy and re-radiate it like heat lamps back to the earth, keeping us warm. So the CO2 is much more powerful than O2 and N2 that make up most of our air. Water vapor is another one. Water vapor is H2O. So again, there's three atoms in an H2O. Let's see, this can be the O this time, and here's a couple of H's. But unlike CO2, they're not all in a straight line like this. They're actually bent like this. So the H2O molecule is even better at dancing and vibrating than the CO2 molecule, because it can go wee woo wee woo like that, but it can also go beep boop beep boop, or it can do this swinging thing. It can even do handsprings. I'm not going to try that here. That would be kind of dangerous. So what does all this have to do with climate change? As you know, when we burn stuff that's made of carbon, like coal, oil, and gas, we react it with oxygen in the atmosphere to make extra CO2 molecules. I'm Scott Denning from Colorado State University.